Good afternoon, fans and subscribers. You are still on to your favorite Mega Books channel. As usual, tonight we shall be discussing on crank and bent of bars in beam construction and design. Now you can see from the video running, we have a beam running between columns and running between various supports. The objective of every structural design is to achieve maximum permissible safety for the structure and the building and the construction itself. Now, every beam is being subjected to what we call compressive strength, and such compressive strength arises from its own weight, which is dead load, and then also from the life load, which is the load of the people and the function and activity that to be subjected to. Now, if the behavior at such instances happen in such a way that at the support of every beam, the shear force is higher, meaning the hugging will now set in at that basis, because the midsection of the beam is being subjected to compressive strength, and then sagging now takes place at the bottom of the beam itself. So we have two moments acting naturally on a beam. Now, the negative moment being hugging at the support, and then the positive moment, which is sagging, taking place at the midsection at the bottom. Now, to be able to tackle such moments and to keep the safety and the stability of such a beam, now we now have crank bars. Now, these are alternative or supplementary bars being introduced. Now, from each support, they are being run alternatively in between your bars. Now, they being run up to a length of a quarter of the length between two support, and then being bent down at 45 degrees for a conventional column. For a conventional beam, are bent at 45 degrees, and then you can see that at the top, almost a quarter of the length, the bars run, and at the midsection, the bars run up to half of the total length, and then be bent up again at the quarter length. Now, the reason is this: they will be able to withstand the shear force, which will now generate the negative moment at the support, which is hugging, which may lead to failure, which may lead to being brittling of the structure of the beam itself, and then be able to withstand the sagging effect, the consequent sagging that happen at the bottom of the beam. So this provides more rigidity, this provides more strength, this provides more stability for the beam, and then consequently for the entire structure itself. The advantages are enormous, because you now have the advantage of minimizing the quantity of materials, the thickness of your beam, and then the number of rebars that you'll be used in your beam construction to achieve the required strength. Thanks for listening. Have a nice day. Thank you so much.